Hey, fearless Chem students. My name is Mrs. Martins, and Mrs. Searing and I are giving you warm-up questions with video answers every day. These are optional for you if you feel like you need the extra practice or your conceptual understanding could benefit from doing these. Please join us in this. The benefit of doing these is that you get to try it, and then you can watch the video and have immediate feedback on how you're doing and and get your answers questioned in one of the ways. Obviously, this is not ideal. We would rather be answering your questions in person, but this is one of the ways that we can do that virtually for all of you guys. So on this exercise, this is called the Conceptual Understanding of Moles. And the whole purpose of doing this worksheet is because moles can turn into a mathematical concept very easily. And that concept gets detached from a conceptual understanding of what a mole actually is, what it looks like, how it behaves, what it impacts. It's just so easy to detach the math from the concept. And so this worksheet, the point of this is to bring it back together. So I want to walk you through how I would approach this worksheet. Basically, I just read the introduction to you, only I didn't read it. And then underneath the introduction, you can see concepts here and then a procedure. And so this is where they're giving you the information for your model. Now they give you a bottle and a little segment of the bottle and all these dots. So underneath they tell you some information about it, like this represents 1 mole of argon gas. The mass in the bottle is 40 grams. And then they give you information in a picture also. So what we can do from this is we can say, okay, how many of these dots correspond to the 1 mole of argon or the 40 grams? And so I'm just going to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 dots. Okay, so what this actually does to me is it gives me these 3 different quantities that are all equivalent. They're all representing the exact same quantity in 3 different ways. We can represent the quantity in dots, we can represent that quantity in moles, or we can represent that quantity in grams. All 3 of these are equal, and you should light bulbs should be going off in your mind right now, because when I have equivalent quantities like this, what can I build? It's all of our favorite thing. It's conversion factors. So I can build a bunch of conversion factors here. I can say 10 dots and 1 mole. I can say, well, let's stick with 10 dots. 10 dots and 40 grams are the same thing. I can say 1 mole and 40 grams are the exact same thing. And of course, like every single conversion factor, if I can write them this way, I can also flip them and they're still equal. 40 grams and 1 mole are equal amounts. 40 grams and 10 dots are equal amounts. And 1 mole and 10 dots are also equal amounts. So I can write a whole bunch of conversion factors off of this one equivalent statement with these 3 quantities. Okay, so with this information, let's go through and kind of process the questions that they're asking us to process. So number 1, how many moles of argon are listed in the bottle? So they give us dots here, and they're going to ask us for moles and mass. So let's see how many dots they have. 16 dots, and we want to convert that into moles. So if 10 dots are equal to 1 mole, then 1.6 dots is in the bottle. notice that I'm setting this up just for the sake of being really consistent with you guys. I'm setting this up like a conversion factor. Obviously, there are other ways to set this up. You could set this up in a proportion, and I think that's the natural tendency for a lot of you guys to set this up as a proportion. The reason I want to be really consistent with conversion factors with you guys is as we build in more and more and more and more conversions, when we do a 4-step or a 5-step conversions, setting it up like dimensional analysis is going to be a whole lot more convenient, and you're going to have a whole bunch of checks built into a dimensional analysis problem to see whether you set it up correctly or not. And a proportion doesn't necessarily have those automatic checks. So that's why I'm going to do everything very consistently with you in dimensional analysis. But of course, there are other ways to do this. So let's go to mass also. If I have 16 dots, and I know that 10 dots is equal to 40 grams, then what do I get out of here? So 4 times 16 is what? 64? I think so. Okay. If you are super stuck on this problem, now would be a really good time to pause this video and go through and try 2, 3, and 4 on your own before you watch me do the rest of those. Okay, so let's keep going. Let's go up to 2. So in number 2, they don't give us dots, they give us moles. So we're going to start from moles here and go to the other 2 things. 0.5 moles, and I want to convert out of moles, and I want to go into dots because dots is particles. So 1 mole, 10 dots, which means I need 5 dots here. 1, 2, 3, 4, 5. Ooh, they're so cute, little dots. Okay, what's the mass of gas in this bottle? So same idea, 0.5 moles, and I want to get out of moles and into grams, and I know 1 mole is the same as 40 grams, so this must weigh 20 grams. Let's do 3. How many moles of argon are in this bottle, and what is the mass? So they're starting me on dots. I have 4 dots. And let's convert this many dots to moles. So I know that 1 mole is equal to 10 dots. So I must have 0.4 moles. And then 0.4 moles. I'm going to go to mass. So I want to get out of moles and into mass. And I know 1 mole is equal to 40 grams. So 0.4 times 40 is what, 16? Okay, again, if this is helping you to watch this video, you might want to pause it here before we do number 4. I'm going to erase what we have and move it down so you can see number 4. All right, and in this one, they tell us that it contains 60 grams. They're starting us at grams, and then they want dots and moles. So 60 grams. And I want to get out of grams and get to dots. I know that 40 grams is the same as 10 dots. So what is that? 60 divided by 4? So 15. So I'm going to put 15 dots in here. There we go. And then I want moles. So 60 grams, and I know that, oh, I'm running out of space. Let's just start this over on the side. 60 grams to dots, and that was 10 to 40, which got us 15 dots. And now I want to go to moles. So dots to moles, and I know that 10 dots is the same as 1 mole, so 1.5 moles. Voila! There we go. Send us questions if you have them. And it would be a good time right now to just pause and reflect on this and maybe write out something that you realized, or an aha moment that you had, or a question that you still have, or maybe how the way that I did it relates to the way that you initially did it, because I'm sure there's a relationship there. And we'll see you guys hopefully in office hours, and if not in office hours, on the next video.